Good morning. The first thing to check is, because I hear people speaking with a foreign accent here, and I also hear that there's a lot of French people living in London, so if everybody is French here, let's not do the talk in English, right? But there are English people here, right? Okay, yeah, so we'll do it in English. I see many French people, well, several. So you will have to forgive my accent. Thanks for coming. I know it was hard. I got lost in the stairs myself. Hard to find. Thanks also for missing Mark Reynolds' talk on modules, because I know it's something that people are waiting for, but I'll try to make up for it by showing you how we have modules in Ceylon. So maybe you can find some compensation here. My name is Stephane. I'm going to talk about Ceylon, more specifically the language, the ecosystem, and those things. I have sort of a plan. There's going to be a little bit of talk at the beginning explaining what Ceylon is and what the language is about. And then we are going to have, most of the talk is going to be demos about the ecosystem around Ceylon and things that the community is building with it. And then we'll finish with a few words about the future of the language. So a few words about who I am. I work for Red Hat. I started on the Ceylon project since it went public. I believe it was something like 4 years ago now. Time flies. I started the JVM compiler. We'll see later on that we have a second compiler as well. I started the herd module repository as well, which is something that I will show during the demos. And I work on various bits and pieces of the Ceylon project. So a few words about Ceylon. Ceylon is first a new programming language. So it's a programming language that is meant to be modern. It's meant to be powerful. It's something that is recent, so it makes sense that it collects all the good things that we learned about programming languages in the past 15 years. But it's also something that sticks to the main feature of Java, the language, which is a language that we use and that we really like. Which is that it's readable and it's predictable. I often ask this question during conferences. I see mostly young people here, so maybe not so many will raise their hands. But how many of you were around in about 95, 96 when everybody used to code in C++ and Java came along? And okay, well, not that many, 5 or something like that. So what happened at the time, for those of you who were not around, was that everybody was coding in C++. It still exists today, right? It's a language that is very powerful, has about as many features as Perl. You can do everything with it, and it came with a manual that was like this thick. But that was not enough, because what you had to have was the guidelines, coding guidelines, mostly telling you, do not use this. Do not use operator overloading, do not use generics, do not use this and that, because then your code becomes hard to maintain, and then your team members will not know how to maintain your code. Java came along, and they took mostly C++ as an inspiration, and got rid of all the complicated, hard, powerful features that allowed you to shoot yourself in the foot, such as memory management. Came and said, okay, well, let's do garbage collection, and got rid of lots of things. And then it turns out that it was a great language, because then people were able to learn the language fast, maintain it in teams, and this is something that we remember from those days, and we think it's still true nowadays, that you have to be able to learn a language fast. You have to be able to understand the code that other people wrote, because most often you write the code once and then you read it many times, and you have to maintain your code. And for instance, I used to code a lot in Perl, which is a language I really liked. But the thing with Perl is that it's a write once and read never language, because once you write a bit of code, 5 minutes later you look at your own code and you can't make any sense of it. So it's very nice for writing code, but really bad for maintaining code. So Ceylon tries to be readable, predictable, and something that works with teams. It's more than a language, though. It's also an ecosystem. It's a full platform. It has modularity built into the language, and we'll see later on how that changes everything. It also has great tooling. This is something where we want to give you all the tools that you need to do your job. So a few words about the language. It's inspired by Java and C#, so the syntax, if you're used to these languages, should be familiar with for you. It features a lot more type inference than Java, so you repeat the types as you type them, very less than in Java. It has a much more powerful type system. We'll see later on what I mean by that, with union types, intersection types. It has flow typing, and again, this is something that I will show in the demos. It has things that people expect in modern languages, such as mixins, lambdas, comprehensions. For those of you who know Scala, this is something that is fairly common. But it has a few things that are really unique, that only this language has, besides the type system. Reified generics, for instance. You know how in Java you have generics, and then you have a list of integer, a list of string, and then at compile time, the compiler throws all this information away, and at runtime you cannot query whether a list is a list of integer or a list of string. In Ceylon you can inspect what is the value of the type parameter element, and it will tell you. It has modules, so we have modularity built into the language. We have a great meta model, which is similar to the reflection in Java, except that it extends through the whole platform. So for instance, in Ceylon, you can query the list of modules that are running for each module, what their dependencies are, what packages they have, and for each package, what are the types defined in this package. If you try to do the same with Java reflection, you can't. You can actually get, when you have a class, you can ask it what package it belongs to, but you cannot list all the types in this package. So for discovery, for instance, you have to rely on third-party tools that do the class path scanning for you and indexing, and modularity is not built in there. So it compiles to the JVM, which is a platform that we really like, but also to JavaScript. So if you have, if you want to run Ceylon code on Node.js or on the browser, it just works, and it's the exact same language. It's not a subset or special rules. It is the same thing. Again, we'll show this in the demos. And of course, because we run on the JVM and on JavaScript, we have a full interop with both platforms. So you can use any library written for JavaScript, any library written for the JVM in Ceylon. So the first thing to see here is the first example of the tools that we give you with Ceylon is the Ceylon IDE. Which is based on Eclipse. It got started by David Vestal and Gavin King. And it's integrated with JDT, which is the Java plugin for Eclipse, which means that you can have Java files within a Ceylon module, vice versa, and they integrate well together, and refactorings work across the languages. It supports everything that the language supports. It's also integrated with the module system, so you get like completion for importing modules. It will query remote repositories and everything. And it's something that is definitely as production ready as the Java plugin, which is, it might sound like not much, but when you think that the Java plugin for Eclipse is about 15 years old, a lot of work went into the Ceylon plugin to make it as feature complete as this. We also have the beginning of a plugin for IntelliJ. Got started by people from the community, Bastien and Mattia. It has already a few features. but it's nowhere near as complete. It's missing all the quick fixes, refactorings, and these things. But the good news is that now we have 2 people working full-time on it since the beginning of this year, so it's picking up speed. And by the end of the year, we should really have something very good, because what we're doing at the moment is taking all the logic for refactorings, quick fixes, and everything from the Eclipse plugin and abstracting it into something that is IDE agnostic. So we can reuse this for every new IDE, for NetBeans, for instance. So let's go for the first demo, because talking is boring. So in this demo, I'm going to show you a demo that I did a few years back at Java 1. The idea of the demo is to show you Ceylon running on the server, on the JVM, and Ceylon running on the front end in the browser, compiled to JavaScript. And the 2 bits are going to talk to each other. So what we're going to have is that the front end is going to run in the browser. It's going to open the socket to the back end and get a list of modules as JSON from the backend and display them to the user. The backend is going to serve a WebSocket, and it's going to connect to the database running locally, extract rows from there, and turn those into JSON and feed them to the client. So we have 2 modules. We have the server module. Let's see this one first. What we have here is the module descriptor for the server. You can see that we have the name of the module, we have the version. Well, this is pretty standard. And we have a list of imports. So we import modules. The first 4, that start with Ceylon.something, come from the Ceylon SDK. Now I need to clarify something here, which is that many people ask us, why do you have your own SDK? It doesn't make sense. The JDK is great. And it is to some extent. If you forget AWT and Corba, it has lots of great things. But the thing is that if you depend on the JDK, which you can, here, for instance, I import also the JDK. Java.base is the module that ships with that provides the packages Java-lang, Java-util, etc. It's the name of the module as defined by Jigsaw, which is the modularity of how they plan to split the JDK in JDK 9. So the list of which packages go into which modules is known for 5 years already. So we pretend that JDK is already modular, and when you import Java base, you get Java lang, Java util, and to be frank, most of the JDK actually. So you can import the JDK, that's fine. But if you want your module to be compiled both on the JVM and on JavaScript, well, you can't really depend on the JDK, because on JavaScript the JDK is not available. There's no JDK when you run on Node or when you run on the browser. So if you want to be able to write something that is, pure Ceylon, as we used to say before 2000, something that was pure Java, right? Then you need to depend on an abstraction of the JDK. And the Ceylon SDK is that. It's something that is available both for the JVM and the JavaScript VMs. So here we use bits of the SDK from Ceylon, bits of the JDK as well to show you interop, and the Postgres module, which is just a JDBC driver written in Java, right? It's something that I imported from Maven because we can use Maven modules as well. So with this, let's see the code. All right. So I have here a function called run. It is shared, which means that it's visible outside the scope, so outside the package. It's at the top level as well. So because in Ceylon we can everything is a lot more regular than in Java. You can have functions at the top level. They belong to the package. They don't have to belong to a class. You can have attributes as well. And the first thing we do in this function is that we're going to get an SQL connection. So you can see here I have a keyword value which says infer the type of this, tells the compiler infer the type of this by looking at the right hand side. So if I hover over it, I can see that we know that getSQL returns an object of type SQL, so the type of SQL is SQL. So let's see what this function does. I create a new Postgres data source. So this is just the call to the constructor of this JDBC driver. I don't need new here because classes are functions in Ceylon. So when you have a class, it's also a function. You can pass it around like any function. It calls a constructor, naturally. So I get this data source, and then I set a few setters, properties, JVM properties, the server name, database, user, password. You can see that I'm not using the set method call. What we did in Ceylon is that we unified fields and JVM getters, setters, properties into a single syntax, where from the outside it doesn't matter how it's implemented, whether it's implemented as a field or it's implemented as a method. From the outside, it looks the same. This is something very users of C# will not be surprised by this. This is so I'm setting these things, and then I return a new SQL object which takes a function as parameter. It's a func, so it takes no parameters. It returns a new connection every time you call it. So let's go back here. Now I have my SQL connection. I'm going to create a new server. New server is something that comes from the SDK. It allows you to run an HTTP server. And I'm going to give it an endpoint, which is a WebSocket. What you see here is a method call. It has curly braces because you can invoke functions with parentheses, as I've done here, or with curly braces. And when you invoke methods with curly braces, you can pass parameters by name in any order which you choose, which makes a lot of sense because in Ceylon we support defaulted parameters. Now this is a bit small, but you can see here we have this constructor actually takes lots of parameters, like on error, on text, on binary, and most of these have default values. So I don't need to pass them all. I only want to pass the path, which has to start with WebSocket, and a callback. Whenever somebody opens the WebSocket, then this function is going to be invoked. What this function does here, it's a function which takes a WebSocket channel and returns void. It's going to call the readSQL function. Let's see what this does. ReadSQL takes a SQL connection and takes a callback. Right? That's a function type. There are real function types in Ceylon, and great support for it. We don't need to pack them into interfaces with single abstract methods and such. So I just want a callback. It takes 3 parameters. I'm going to do a SQL select. I have a database running with all the modules published to the module repository. I'm going to iterate over the rows, and here you see again, here type inference, but here also type inference. I'm not specifying the type of the row. The compiler knows that rows is something that is iterable of map string to object. Each row is a map to a column name to a value. So I don't have to specify the type. The compiler is smart enough to understand that, right? I spend most of my time in Java actually repeating and trying to quick fixes to infer, what's on the right-hand side. I know it. And here we're going to do flow typing, which says I'm going to check that the types of the objects I get from the row are of the right type. So I'm going to check that the name, the version, and downloads are string, integer. And within the body of the if, then I have these new values defined, and I know that they are of the right type. I'm going to call my callback with name, version, and downloads. And what my callback does here, it takes a name, version, downloads. It's going to create a JSON object. JSON object is again something that comes from the SDK. And it allows you to represent JSON values. Now here at this time, the single arrow is a tuple of key to value. So it's the equivalent of map.entry if you use to the JDK, right? It's the tuple of key to value. What I'm doing here is creating a JSON object with the name version downloads. And if I look at the type of this thing, well, it might be a bit small. Sorry for that. You can see that the values, the type of values that it would accept, this constructor of JSON object, is the set of values accepted by the JSON standard. In JSON, you can have values of type string, integer, float, boolean, a number of things, but not anything, right? So what I'm saying here is I have a union type. It's this thing with a pipe. It says I take a string or a boolean or an integer or any of those types, but not anything else. If you were to try to do the same thing in Java, where you don't have union types, you would have to say, okay, well, I accept a JSON value. What is it? What's the common supertype between all these? It's the only thing you can express. It's Java-lang object. The common supertype between string, integer, boolean, etc. Not special types, it's just the standard types, right? It's Java-lang object. So you would say, I accept a list of Java-lang object. And you're completely breaking all the checks that you could have at compile time, and you would have to exchange them and at runtime throw if it's not one of them. In Ceylon, here I can accept, so name is a string. I can put true, because booleans are allowed. I can put 1.2, floats are allowed. One thing I cannot do is put a SQL connection in there, because that's not part of the union type. It's not allowed. So the type checker, you know, is smarter, is fine-grained. You can express your types better with union types. So what I do here is I create this JSON thing, I print something on the console, I send it over the WebSocket pretty-printed, and then I sleep a bit so you can get to see things appear in sequence. And then I start my server on this socket. So now is when I remember to start it, because otherwise the demo just does not work. Now let's go back to the other part of this, which is a client. So we've seen a server here, which opens a WebSocket server socket, waits for a connection, and then when it gets a connection, connects to the database, gets the list of modules, send them as JSON to the client. Now let's see the client. The client is another module. We're going to compile it to JavaScript, so I don't import the JDK anymore. I import the JSON module from the SDK, and again, it makes sense because once you're used to the SDK, you have, for instance, I'm very used to the collections in Java. I've been using them for 15 years, the new collections. That knowledge is worth something. You know when you need to use a hash map, when you need to use an identity map, a hash set, a tree set. You know exactly your way around collections, and that's one of the hardest problem in computer science, knowing which data structures to use properly. And then you go and you do some JavaScript, because we all end up doing JavaScript at one point or another. And okay, I need a set. There's no set in JavaScript. There's no collections. You have array, and that's it. You have sort of maps, but not really. So all this knowledge that you have of data structures and algorithms, you feel completely naked in JavaScript because you don't have these. Whereas if you code in Ceylon, for instance, once you're used to all the data sets, data structures that you have in Ceylon collection, you can reuse them even if you run on JavaScript. So you can reuse your knowledge of the API. It makes you very proficient, very efficient, fast. So here, I'm going to use the JSON module. No, that's not what I meant to do. And let's see what this is. So I showed you how we do interop with Java. You saw that it was pretty fluent, and the reason for that is that Java, like Ceylon, is a strongly typed language. It's a statically typed language, so we actually at compile time know what APIs we're talking about. In JavaScript, it's very much the opposite. JavaScript is a dynamically typed language, and so there's no knowledge of which API is available on JavaScript. So whenever you want to do interop with JavaScript, in most cases you will have to enter a dynamic block. So a dynamic block allows you to unplug the type checker, partially. You were saying to the type checker, look, if there are things that you know exist, types, functions, everything. Then please check them for me. I want, meaningful error messages. In the IDE, you get completion, everything. If there are things that you don't know about, then do as you would in JavaScript and say, okay, well, it's going to work out just fine. Trust me, I know what I'm doing. For instance, here we're calling WebSocket. This is something that is provided by the browser. So it's going to be available at runtime, but at compile time, we have no idea. This is just the DOM API, right? jQuery, again, it's just the jQuery.js. It's nothing, no Ceylon wrapper, it's just jQuery. So what I'm doing is I'm creating a WebSocket to my server, getting a jQuery thing to have a target. The type of this thing is dynamic. Again, it's not value. It's not something we can infer. We don't know what the type of this is. We're going to register a callback. Returns void, takes a dynamic event on every time we get a message on the socket. What we do in this is going to be very similar to what we did on the backend. We're going to parse the JSON. We're going to make sure that it's a JSON object and not an array or a Boolean or something. Assert is also float typing. It allows you to say it's the equivalent of if, except that the else has a throw assertion exception. So if it's not true, then we're going to have an exception. If it's true, then we're going to have this JSON thing. We're going to check we have a name version downloads from the JSON object of the right type. And then we're going to do a bunch of standard jQuery to create, for each module, create something visible on the user interface and show you the name, the version, and we're going to show it. This is if you were to write the same thing in JavaScript, it would not be less verbose, right? I hope you guys see that. No? Anybody has ever written JavaScript code here? I feel like I'm the only one. 2, 3? Oh, okay, you're just shy. All right. So you've probably written jQuery code, right? Okay, so this is. Does this look different? No, right? This is interrupt with JavaScript. It's not that bad. Now let's see here. Let's fire this demo. When I click this button, it's going to run the module, it's going to connect to the WebSocket, and for each of them, it gets on the WebSocket. The callback is going to be called. I'm going to show the name, the version, and the number of downloads for this. So let's see. You must be thinking there's got to be a lot of boilerplate here, but really very little. This is the entire HTML page. We have some standard content type, a bit of CSS. I import jQuery because I'm going to use it. I import require.js, which is the module system we compile to. There are, I think, 2 module systems for JavaScript. This is probably the most popular. I'm going to tell require.js that my modules are sitting here. And then I have a bit of jQuery, a standard thing that you would do in JavaScript. You say, when the document is ready, I'm going to call require.js, tell them I need this module to be loaded. When this module is loaded, then I'm going to register a click handler on the button. When I click it, I'm going to call the run function of the client module. And that's it. And then here I have the button. It does nothing unless I plug it. So there's very little boilerplate, right? I'm only using jQuery to say, well, when we're ready, I want to call this function on this module. So that's the first demo. Let's go back here. So I talked a bit about the SDK. The first thing to note here is that modularity really changes everything. And so when you download Ceylon, you don't actually get the whole SDK. You get a single module, which is the language module, which is a very small module, which has the primitive types, which are not actually primitives. Everything is an object in Ceylon. You don't have special holes for primitives that sit outside the type system. Naturally, when we compile it to the JVM, we do use primitives everywhere that it would be possible, right? So it's still as efficient as if you were using primitives. We have a few interfaces to represent collections, no implementations of them, but interfaces. We have the type of every function, which is callable, able to represent functions of any number of arguments. A bit of information about the system, such as what's the version of Ceylon running, or am I running on the JavaScript VM or on the JVM, and the meta model, which allows you to inspect the running program. All the rest comes from the SDK, which is available online on the module repo, and which you can download between releases. We can have bug fixes of new features on any of these modules, and you only download the ones you need, and you don't need to wait for a new release of Ceylon to get a new release of the SDK. And this is something that is very, very handy. Most of these are available for both backends. Some of those are not, either because it doesn't make sense or we lack time to do it. For instance, the file system on JavaScript, it's, on Node.js it would make sense, but on the browser, much less so. So another demo is going to be about some other tools that we use. How many people here use the command line terminal? All right, most of you. Good. So like I do. We spend a lot of time on the command line, and so we also spent a lot of effort getting it right. So we took a good example, which is the Git command line, which is something great that you may not realize is really great, which is that there's only a single command. So that means that whenever you type Ceylon, then you get completion, and you can discover all the other commands. This is very important because most people, for instance, when they get the JDK, they don't know the commands that ship with the SDK, with the JDK. For instance, most people don't know they have Visual VM there because it doesn't start with Java. So they do Java and then completion, and they get like, I don't know, 8 things. And they never know about the rest. And it's very important. So, for instance, here, let's kill this one. Let me show you another module. It's not this one, it's not this one. It's here. Going to show you another module which says hello, it's very polite, then connects to GitHub to get the list of repositories for the Ceylon organization. Because I hate relying on internet for demos, I have a local copy of this API running here, but that's what it would do. I'm going to connect to this, going to parse it as a JSON, make sure it's an array, iterate over each value of the array, and again, you can see union types here, where I get every element of the array is a string, a boolean, integer. I'm going to make sure I have an object and that I have a name, number of issues. I'm going to print the name of each repo we have and the number of issues in each repo. Let's go to the command line. Okay, so I have Ceylon command here. I have completion. I can see, okay, how many commands do I have? I have a number of things. I can compile. I can copy modules from one repo to another. I can run the documentation generator, import jars into my repo. I can show information. I can publish things to OpenShift, run things. I can test things. I can change the version numbers. What I want to do here is I want to compile my module. I don't have you have to realize here, I don't have a build thingy. I don't have a build descriptor. I don't have nothing. I tell the compiler, just compile the modules. It's smart enough to find the modules, find their dependencies, download them, set up your class path, figure out the number of files it needs to compile, and compile them. Try to imagine doing the same with Java C. It's another thing. Okay, so I've compiled it. Now I want to run this one. So I tell it, this is the name of the... no, that's not the one I want to run. You idiot. So I just tell it the name of the module, the version, and it will just pick it up. It will, again, pick up the dependency, set up the class path, find the main function, call it, etc. It does all this for you. So in most cases, you don't even need a build thing. Of course, if you do need, then if you need something more complex, you can. But the tools by default are friendly, right? Let's go back here. And that leads me to Ceylon build. Ceylon build is something that got started by another member of the community, Loïc. And the idea is to let you write your build in Ceylon. It's very inspired by Gradle. And again, it's something that makes a lot of sense. For the same reason I said earlier, once you've learned about the language, about the API, about everything, the ecosystem, it makes sense that you don't have to learn another language to write your build. So let's see what this can do. I have here, by convention, the build descriptor and the build module is going to sit in a different source folder. I have a build module here. It imports the build engine, which has all the annotations support for describing your build. And the Ceylon tasks, which is the ability to call the Ceylon command line tools. So the compiler, the documentation generator, etc. So I'm going to show you a very trivial example here. We're going to elaborate on it later on. So here I have a top-level attribute that says that the module I want to compile is this. And I have a function called compile, which has an annotation here. We don't need the @ symbol in Ceylon. So I have an annotation saying goal, which means that I can call it from the build. What I'm going to do, I'm going to print something on the command line, and then I'm going to call the compiler of Ceylon and compile this module. So I go on the command line here, and you may have noticed I have build as a possible target. And this is not something that ships with Ceylon, actually. The build command is a plugin. So you can install it, it will pick it up. We support plugins in the command line, so that's pretty cool. OpenShift is a plugin as well. So now I can say build compile, and it's going to call the compiler and compile it. Okay. So, you know, trivial example, not very convincing for why you would need a build system, but we'll come back to it. So first I need to talk about herd. Herd is the module repository that we wrote for Ceylon. This is what you get when you go to modules.ceylonlang.org. You get the list of modules that we published. It's the equivalent, if you will, of Maven Central, but then for Ceylon. And the idea is to make it first open source. So it's something that you can use yourself. You can download it, run it, the exact same thing privately in your company or publicly, whatever. You do what you want with it. But the big idea is to make it really as pretty and usable as GitHub. So we want something that is easy to use, easy to understand, easy to manipulate. Because we thought that it was really hard to do with other module repositories. Works with teams, of course, and there's a social aspect as well, which can be useful. For instance, you can get an item or SSS flux of which modules have been published. So you can say, okay, I want to be notified every time there's a new version of Hibernate, or every time this guy writes a new module, because he's a cool guy. Let's see what this does. I have a demo here. This is what it looks like. You can browse, for instance, modules by category. You can see the SDK. You can see we have a number of things. You can see that collection has a number of releases. You can see that, for instance, you can browse the documentation. And this is again something we spend some time on. When you hit JavaDoc, the first thing you do is you try to find documentation about this type that you're looking for. And there's no search, so we fix this. Hash set. You can navigate with your keyboard just with a few keys, and you go to exactly where you want to go. That's all client side. It's pretty useful. So what we're going to do here is that we're going to take our module here, and we're going to publish it to herd. So the thing is, it tells you, publish your first module, what you need to do. You register, you claim your project, which means that you ask for permission to publish this thing, because not everybody should be allowed to publish a new version of something that should be secure, right? Once you get permission, you just create a new upload. I create a new upload. That's a private repository on which I can push all my modules, and the system is going to check that they're valid, that all the dependencies are here, that it's compiled properly, etc. And you can test it there before you publish it. So you get this URL on which you're going to be able to push the things. And that's where it starts making sense to have a programming language in your build. Because if you hard code this in your build, you're going to tell the compiler, look, publish this to this repo, but this repo changes for everybody. Your username also changes, so you're not going to want to hard code this in your code, in your build. So it makes sense to have a process that is interactive. We're going to ask you on the command line where you want to push it, what's your username, what's your password, and then I'm going to call the compiler and tell him, look, instead of compiling here, just compile it to this remote repo. And again, for documentation, we're going to generate the API docs, just generate them to this remote repo. So let's go here, Ceylon build, publish. It's going to ask me the URL, username, most secure password on internet. So you see it compiles it to the remote repo, it generates the documentation over there, and I go back here, I hit reload, and it says, oh, I have a module. I have a warning. Why? Because I did not compile it to JavaScript, but that's fine for this demo. I'm just going to publish it. And now it's there. If I go look for it, I can see version 1.8 was published 6 seconds ago. That's how easy it is to publish things to Herd. And that's the exact same thing you get online, right? So the last demo I want to do is about Vert.x and Kyla. How many people here know about Vert.x? Oh, please, at least more than one hand? 2? 3? Okay, not many people. So Vert.x is something that is led by Tim Fox, works for Red Hat as well. It's an implementation of Node.js on the JVM. So for the people that like Node.js but are a bit, cautious about JavaScript and would like to use all the amazing ecosystem of the JVM, then you can write it in Java or in JavaScript. It's language agnostic. Vert.x it happens to be written in Java, but you can write your verticals in Java, JavaScript, Groovy, and Ceylon. So it got started by Julien Viette, the integration between Vert.x and Ceylon, who's now working for Red Hat. It consists of a number of things. The first one being the Ceylon promise module for the SDK, which is an implementation of the A+ promise specification. Allows you to chain promises and futures, if you will, and do composition of promises. And it's also the integration with Vert.x, so you have a Vert.x module in Ceylon. You can just import the Vert.x module, run Vert.x, etc. And you can also, the other way around, when you download Vert.x, you can write your verticals in Ceylon. It will just pick it up, compile them, plug them, and everything just works. And then there is this thing called Cayla, which is a web framework, well, the start of a web framework for Ceylon. It uses Vert.x underneath, and I'm going to show you a bit of it now. So here, so I have this module. I import the Cayla web framework, and again, because of modules, that's all I have to do. I don't have to go download the web framework, compile it, or configure it, install it, whatever. Just import the module. What I'm going to do here is proxy to the Chuck Norris database fact, because that's about the most useful thing I could find on the internet. And again, I have a local copy. The way it works in Vert.x is that I declare a controller, which extends a handler, which is a type defined by Cayla. I have an annotation saying this is the route for which I want my controller to be invoked. And then I have an invoke method that I override, which is what actual says. And as you can see here, I don't return a response, I return a promise of a response. So this is really asynchronous programming. I'm going to get the runtime, the Vert.x running underneath, create an asynchronous HTTP client, and I'm going to get a request to the checknoise database fact. And this request is really a promise of a request. So I can get the response. This gives me a promise of a response. Again, asynchronous programming, which I'm going to compose with parsing the response. So whenever I do get the response, I'm going to parse it. And whenever I'm done parsing it, I'm going to compose it with a transformation. What transform does here is it takes the JSON object I just parsed, going to make sure I do have the joke, and then I'm going to return OK response, and the body of the response is going to be template. In this case, I want to call the index method, which is here. And there are a number of template systems for Cayla. I think there's Mustache is one of them. And this one is pure Ceylon. So here what I'm doing is not a DSL, it's not something special. It's just chaining a bunch of constructors. So HTML is a type. I invoke it, I pass it a head, a title, I pass it a link with a style sheet, and again, passing parameters by name. And this is where you see where it starts, making sense why we did all this. And you can see and this is where it shows that I'm French and I cannot pronounce it, the hierarchical, right? I have lots of trouble with this word. The hierarchical structure of the code. Frankly, it's a lot easier to pronounce in French, hiérarchique, at least for me. It's the same word, but a lot less syllables. You can see whatever it is that you're returning to your client, right? If you try to do the same thing with getters and setters, you would have to do, okay, new HTML, I need to create a local variable for it. And then, set head, set body, and then it becomes spaghetti, and you don't see anymore what you're going to return to your client. This way, it's a lot more obvious. So I'm going to create the application, pass it a package literal, which says, this is the package I want you to scan. It's going to scan the package using the meta model and see all the routes I declared. It's going to run on 8081. Again, let's not forget to start it. Thank you. And I have it running here. What? No. Okay. So every time I hit reload, I get a new joke. I'm running short on time, so I should go back here. Let's talk a bit about the future. Before I can explain the future, let's talk briefly about the past. We released version 1 at the end of 2013. Version 1.1 at the end of last year. It was mainly improvement in compilation speed, runtime speed, and lots of bug fixes. But very few changes in the language. We're working on 1.2 now. It should come out right after summer. We have a number of things like serialization, the ability to send objects from any VM to any other VM. So for instance, if you're running in JavaScript VM, you can send your objects to a JVM. So using whatever representation, it's a representation agnostic. It could be XML, JSON, whatever. Better flow typing in expressions, let expressions as well, which is always handy. The ability to have more than one constructor per type. This is, I will not get into this, but this is useful sometimes. Number of things really. 1.3 is the roadmap is not, the number of features is less clear. Most of these are actually implemented right now. We're just working on bug fixes at the moment. And 1.3 should come out next year with a number of other features. But again, the roadmap is more open. So if you feel like something missing with the language, or you would like to see something changed, then you can contribute to this and contact us. Everything is on GitHub, everything is open source, the IDE, the tools, the module repo, the language, everything. So you can go and find us and hopefully give us feedback, tell us, this is good or this is less good, what do you want to see changed. We're very open about this. Everything is, of course, done in the open. And let's see if I have a little bit of time for questions. Oh, come on. Yes.
I'm curious about what's the adoption of this at the moment. Is there some known big or small project using this, using Ceylon, or I mean, just want to know if there is some traction in the industry.
Right. So the question is about adoption. If we have clients or users, or we don't have clients, obviously, because it's not productized yet. So it's still open source, or just open source. There's no support for it from Red Hat. We do have a number of users, more and more every month. The mailing list is really going really fast. I can't quite tell you how many users, or we don't have big companies using it yet. But I can tell you that we have about 3 different people working on build tools. I think we have 3 web frameworks started by people, again, by people of the community, not by something we control, right? I think we have 2 parsers being written in Ceylon as well, 2 or 3 parser combinators as well. So there's quite a lot of development going on in the community. What I showed you, like the Ceylon build, is something that got done by members of the community. Cayla, for the biggest part as well, was. So there's lots of interest and of users, and frameworks are being written. So, you know, is it better than other languages? I don't know, but is it good? I think so, yes. Yeah. Okay, one last question. Thank you.
Are you using it in production internally at Red Hat?
Are we using it in production internally at Red Hat? No, not at the moment. What we're doing, though, is integration with all the other tools. So we're working on integration with Hibernate, with OpenShift is already done. You can write your OpenShift application in Ceylon, with Vert.x as well. So what we're doing at the moment is making it easy for everyone to integrate with the other products that we have. But we haven't started new projects at Red Hat in Ceylon. No. Thank you for coming. Bye.